Okay, so we have this function here, and we want to figure out all these items. So let's just start off with the first one right off the bat. We want to find a point where the derivative is negative. Now, there's more than one point, of course, but the derivative is negative anywhere where the function is decreasing. So anywhere, you know, right along here or right along here. Those are all points where the derivative is negative. Now that's different from where the function is negative. The function is negative is when the function's below the x-axis. So that's only right here in this area. So any point right there below the x-axis would be a point where the function is negative. And then a point on the curve where the derivative seems the largest. Now this one is not as easy to see, but notice how if you're looking at the slope of the tangent line, for example, right here, the slope of the tangent line, or in other words, the derivative, right here it's 0. And then it starts increasing and then increasing. And then what starts happening is, well, it has to go back to 0 again, because right here it's 0 again. So right along here somewhere, it starts decreasing. So that point where the derivative seems largest, that would be, a point kind of like right there. And remember, that's called the inflection point. Now it's not 100% clear if that's the largest. It could also be right there, but just by looking at it, that's where it seems like it is. Now, a point where the derivative is 0, that's what we were just talking about. Anywhere right here on one of these two spots is where the derivative is 0. So either one of those points would be where the derivative is 0. And then 2 points where the derivative is about the same, we're going to mark E and F. So that's not too hard to find. For example, something like right here, let's call this E, and then maybe right here, let's call that F. So they look about the same. So that's it. Okay, so here we've got a function, f of x, and we know that f of 100 is equal to 35. So that means that when x is 100, y is equal to 35. And then it also says that f prime of 100, so the derivative is equal to 3 at x equals to 100. So basically what this is telling us is this is the rate of change, or this is also telling us the change in y. This is about the change in y for every change in x. So if let's just kind of draw a picture so that I can show you kind of what I mean. Let's just say hypothetically that this function looks kind of like that, sort of. And let's just say that this point right here, this is 100, and so then the y value right here would be 35. So what this is saying, when it says the derivative is equal to 3, that means that if you go over to, let's just say this is 102 right here, that means that if you go over 2, then you would go, since the slope of this line is 3, well then that means that this guy would be up 6. But notice that this line and my function, they're pretty close. So what you could say is that f of 102 is approximately equal to 35, which is right here, this starting point. and then plus this much right here. So you don't know what this is really, but you do know that from on this line from here to here it would be 6. So you're going to say that that's approximately 35 plus 6, which is 41. So that's your approximation. So in this example, this is kind of like the previous problem that we just did, where we have this value. We know f of 5 is equal to 20. So we know that the coordinate for b is going to be 5 comma 20. So we know that because we're given the value of the function at 5. And then the other thing that we know is that the derivative at 5 is equal to 2. So what that means is that the slope of this tangent line is equal to 2. Okay, so then if we want to find, for example, this point right here, C, if we want to find C, well, we know that we're going to add this much to whatever the value for B is. Okay, so how do we find that value? Well, we know that from here to here is 0.2, and we know the slope of that line is 2. So then what this is, the rise, is simply the slope 2 times 0.2, which is equal to 0.4. So then what that means is that, so for C, I have the x value, which is 5.2, and then, the y value is going to be whatever the y value is right here, which is 20. And then I'm going to add what I just found, 0.4. So this is going to be 20.4 for the y value, because I know that this distance from here to here is 0.4. Okay, now for A, the idea is exactly the same, except now I'm going to subtract. So here the x value for A is 4.9, and then the y value, notice though that A is lower than B. So when I look for, here I'm looking for this height right here from A to B, this is going to be the slope, which is 2, times the difference between these two, so the distance from 4.9 to 5, which is 0.1, and this is equal to 0.2. So this time, though, I'm going to subtract 0.2. I'm going to subtract it from the y value. So I'm going to subtract from 20. And so then that means that my y value for A is going to be 19.8. And that's it. Those are my 3 coordinates.